All right, and we are back. Joining me now is John Crowley. He works for the University of Alberta. John, why don't you start off by talking a little bit about what it is you do?
So we're with the animal science part of University of Alberta, and we've got a little kind of a spin-off arm, you could say, called Livestock Gentech. And really we do animal genetics and genomics. So and looking at genomics in a bid to breed better animals. So I guess the main problem that we address is food production. We all know that the world population is increasing. Coming with that will be an increase in food demand. So by 2050, the FAO want an increase of up to 100% in food production. So we need to do that with our animals, whether it be dairy, beef, pigs, cervids and deer. We got to do that with the same amount of resources we have now. So increase in production efficiency. So we do that through breeding better animals using genomics.
Very interesting. So we talked a little bit about this before the cameras were rolling, but now that we're live, why don't you talk a little bit about the difference between what it is that you do and the genetically modified organisms, the GMOs?
Okay, so a question that does come up a lot, and especially when I start telling people that I meet for the first time and what I do. So GMOs, genetically modified organisms, usually relates to some type of manipulation of the genome artificially, maybe in a lab or whatever. What we do is actually we breed animals, so kind of an aid to traditional animal husbandry. We don't actually modify the genome, we breed the best with the best, and you could say hope for the best. But with genomics and actually looking at an animal's genes, we can do it a lot more accurately.
All right, so almost building on what people have been doing for hundreds of thousands of years.
Exactly.
All right, so what role does analytics play in what it is you do?
So if you take a genome of an animal, their genetic code, very similar to humans, 3 billion base pairs long. So their genetic code is 3 billion pairs of letters long. And that's just for one animal. So that's a lot of data to interrogate. And once you do that on multiple animals, next thing your database is very big very quickly. So we got to analyze this for differences. We look at animals, we measure phenotypes in the animals, then say we'll go with milk production. We know what animal, just by measuring an animal for milk production, we can see whether they're a high producer or a low producer. Then we can look at their genotype, or their genetic code, and elucidate differences between the high and the low, and see what part of the genome plays a part in increased milk production, and we can breed for the future.
Very interesting. So how did you become involved in this?
How did I become involved? I'm from Ireland, and we have a dairy farm back home. We had beef cattle as well, and always interested in breeding better animals. Ireland's actually one of the leaders in animal genomics and breeding. So from a very early age, my dad is a good proponent of technology, and he was using it from when I was a young kid. So I saw what he was doing, and I always wanted to know how the technology was produced for him to use it. So did animal science, did my PhD in genetics, and ended up in Canada about 2 years ago on this project called the Genome Canada project.
All right, so you said you always wanted to know how the technology worked for this. So can you talk a little bit about how the technology does work?
Sure. So when a farmer is choosing what animals he wants to go into his milking herd, we'll go with dairy.
Sure.
He's got to look at what the genetics of that animal is, what their potential is for milk production, along with other traits such as fertility, health, and actual body frame. So this is all indexed, and all this information is given back to the farmer in a nice, easy to read format, in the form of breeding values. It's like a genetic merit score. So this is the side of it I always saw as a young kid, but I was always interested in the other side. Well, how was all this generated? And up until recently, it was all generated through what we call pedigree analysis, like how you'd say, if you wanted to relate it to humans, it'd be like family trees. Like, so this family on this line, they're good milk producers. But now with genomics, it's increasing the accuracy and the speed at which we can improve genetic merit of our animals by actually looking at the genes not just the familial structure.
All right, interesting. So, when around did you or did the switch from the pedigree to the genomics occur?
It's not so much of a switch; they more complement each other now. So I guess it's around 2000 that the 2002 that what we call genomic selection, the premise for that or the idea for that was generated, and it's picked up. It's kind of snowballed ever since, and it's increased adoption at farm level very quickly. Has worked very well in dairy because of the uniform population of dairy. Friesian and Holstein genetics make up a lot of the percentage of the worldwide dairy herd. With beef, there's a lot more breeds, a lot of variation in genetic structure. So it's one of the challenges that we at the moment we're addressing at the University of Alberta in livestock GenTech is to get genomics working better in beef cattle.
So fairly recent development, the integration of genomics.
Very
into
much
this.
so, yeah.
What do you think the future holds for this?
This science?
Yes.
It's moving so fast. A few years ago, it cost I guess $10,000. No, even more, $100,000, and about 6 months to sequence a whole genome of an animal. And it's down, in a few years we'll have a genome of an animal in a day for $1,000. So that the science is moving so quickly. I definitely see, for the consumer at the end of the day, an increase in quality of product, an increase in supply, which will address the increase in demand coming from the increase in world population. And we hope to do it in an environmentally friendly manner by also looking at animals with reduction in methane.
Great. Interesting. So it sounds like it's certainly going to be moving forward. I know with when it comes to sort of dealing with genetics and food, a lot of people have various ethical concerns. Do you see any ethical concerns in that?
I mean, not for what we do. Everybody has their own view. I would just encourage anybody that has these views to educate themselves properly. And some people seem to be miseducated, and they read one article and they go with it. I'd encourage people to see what's out there. And I said we're not exactly GMO. Well, not exact. We're not at all GMOs. But I have been asked in the past what my view on GMOs are, and I mean, if it's feeding the world where they need to be fed, if there's people starving in Africa and GMO is the answer to feeding them, I don't see how there can be much of an ethical issue there.
All right. You talked a little bit about people sort of maybe having some misinformation or, looking at one piece of information and basing their whole opinion off of that. So I guess do you have any suggestions on where people looking for more information on the subject matter could go, or some good resources they might be able to access?
I guess our website is actually a good place to start. We've got a little box there, and it's called Ask a Geneticist, and you can ask a geneticist any question you want. It's www.livestockgentech.com. So that's a good place to start. But a lot of your interests or your activist groups, they tell you one side of the story, but there's a lot of good science on the other side that I'd encourage people to read.
Fair enough. Have you run into any issues with activists or people sort of coming out?
Oh, none.
None.
No. The only activists I run into are my vegetarian or friends like that talking to me on a Friday night maybe, trying to convert me.
Trying to convert you to vegetarianism. All right, not going to happen anytime soon.
Probably not. I do like my steak. I don't know what my dad, the dairy farmer, would do if I came home, Dad, I'm vegetarian. I don't know how that would go down.
Might make for an interesting family discussion there.
Indeed.
All right. Well, I can't think of anything else to ask you. So thanks very much for appearing on our webcast.
Thanks for having me.
Hope you enjoy the rest of the conference. I'm sure we'll see you around.
Thanks very much.
Okay.
Cheers.
Thank you.
Join the conversation next year as more cities become data-driven. Become a community partner. Contact us at info@abctech.ca.